Let's settle down. Give everyone an extra 30 seconds, a minute. Welcome, welcome. Thank you for coming. It's actually my first public talk in person, I think. I started doing that about like 1 or 2 years ago, so during the pandemic. So I was mainly doing it online. All right. As you can see, today we are going to, or I'm going to discuss this with you on where do we put infrastructure as code of your services. Actually, maybe it's a little bit misleading because I will also speak a little bit about infrastructure as code in general and putting it somewhere. All right, and nice animation. About me. So my name is Timur. I'm from Kazakhstan. I live in Germany, and I mainly built my career as a AWS/cloud consultant or cloud architect, like building different cloud-based solutions for customers, like on top of AWS, on CloudFormation, Terraform, stuff like that. And currently I'm working as a senior DevOps engineer in the core infrastructure team of a Berliner startup, Timur Bublik. I'm also a co-organizer of a meetup, Berlin AWS user group. So if you are in Berlin for whatever reason, just having a weekend or a week over there, I think the next one is going to be in November. It's like every month, every second Tuesday month, just free stuff. People are talking to each other and networking and stuff like that. There you can see you have my contacts if you want to reach me out, ask something, propose something. I mean, not propose any like job offerings, but I'm not open for that right now. But if you just want to chat or something, discuss this presentation, something. Actually, I would really prefer if you would give me a feedback on how did I do today, how can I improve. And the next one, that's the agenda for today. We'll start with small introduction of the company I work at. I think it's also important that so that you would understand more on the scale we operate in, so that you could also adjust what I'm talking about to the size of your company, of your challenges. Then I will give you an introduction into the problem I have today, because not everybody is from the same field. There are a lot of DevOps engineers or DevOps engineers, but not everyone has the same kind of experience. So I'll just bring everyone to the same denominator, and then we'll speak about different solutions for that. So defining infrastructure as code and putting it in the service repository, putting it into a monolithic repository, putting it into a team-specific repository. Then we'll speak about the platform infrastructure. Yes, just a little bit. I'm not going to really speak what is that, how to do that, and stuff like that. Just from the infrastructure as code perspective. Then I'll give you a real-life example of what we did with the infrastructure as code. Again, repository-wise, and also speak about self-servicing, because this is also something related to infrastructure as code, and also needs to be stored somewhere. And eventually we'll just wrap up, and hello, welcome. And then there'll be a small Q&A, I guess. All right. First, so Timur Bublik, it's a probably quite a well-known company in some cities, depending on if there is a bunch of scooters on the streets. Then you probably might know it. So if you're from Warsaw or from Berlin, you probably know this company. But if you're not from those cities, so it's a micromobility provider operating in 260 plus cities in 22 countries across Europe and the world. The company was founded in 2018, headquartered in Berlin. There's 1,400 plus people working there from 104 countries. And having all that, you could see that we operate on a scale of hundreds of thousands of vehicles and millions of vehicle trips. That means that we have quite a cloud infrastructure where I think right now we're operating at 280, 300 Kubernetes nodes in production only. And they are unified in a couple of dozens of EKS clusters. So now let's talk like what is it all about today? So imagine that you have a web service developed by a software developer or a team of many software developers, and it is operated in-house. I think it's pretty important because if you have a consulting company doing all that stuff for you, you don't really care about infrastructure as code. They take care of it. So let's call this imaginary service an invoicing service. Something happens in your company and they are issuing an invoice to the clients or customers, whatnot. So this service might run on-premise or in cloud. It doesn't really matter. What is important is that the infrastructure is definable or defined as code. Because we know there's already solutions for on-premise that you can already manage with Terraform and stuff like that. So what's important is that your infrastructure is defined as code. And this could be it could be any tool. It could be Terraform, CloudFormation, it could be Azure RM, it could be Pulumi, whatever. Like any tool that is commonly known on the market, anything will do. Just for your information, at Timur we're running. It's okay? All right. At Timur we're currently running our infrastructure with Terraform. So when I will mainly speak from this perspective. So if you're using something else, then you should just adjust it to the details and all the small things of your tool of choice. So for example, Terraform requires you to have a state, and CloudFormation doesn't require that because they manage all that stuff for you. So just keep that stuff in mind. But I'll try to have it as generic as possible. Yeah, what's next? Next, you have your infrastructure as code, and you gotta run it somewhere. And I would say for this presentation, it's better to concentrate on the part of having it running in the CI/CD pipeline. You could have it running locally, but then just a couple of points of these presentations maybe will not be really useful for you because I will also speak from the perspective of CI/CD pipeline. So it could be any provider. It could be Jenkins. It could be Spacelift, Terraform Cloud. It could be Azure DevOps. It could be Circle CI. Whatever taste you prefer. And what kind of infrastructure could it be? Again, anything. It could be database management systems. It could be virtual machines. It could be clusters. It could be secrets. It could be anything. But that's a bit too abstract. I will give you like a complete example of what we're talking about. So at Timur, for example, we have hundreds of microservices that are driving our business, and they like any kind of microservice, right? From registering service users to issuing invoices to controlling vehicles, all that kind of stuff. And we operate everything in cloud. So it's on AWS, and the infrastructure is defined with Terraform and is running in Spacelift. It's a CI/CD provider for Terraform and Pulumi and CloudFormation. Yeah, it's a cool stuff. It's actually, I think, developed here in Warsaw. Yeah, something like this. And now I have actually a question to all of you. Who of you already have infrastructure defined in code? Raise your hand. 1, 2, 3, 4, 5, 10. Okay, and who is just planning to do that? Thinking like, our company thinks we will probably need this, or I think our company needs this. Okay, 1, 2. And there are people just say like, I don't care about infrastructure as code. I'm just here to learn something. All right, the numbers don't add up, but okay. All right, let's have a look at this diagram. This is one of the issues that you'll have with some of the solutions that we will discuss in the next slides. So I want the problem defined clearly. So you have a team one that has a service A and service B developed, so they're responsible for it, for running it and developing and all that stuff. And you have team two that is responsible for service C. And now imagine that the management or CTO comes and says, now I want the team one to take care of service C because I want team two to concentrate on service D. And the issue is that with certain solutions, it's going to be a bit more difficult to shift the infrastructure from one team to another. And that's what we're going to discuss. So we have three options. We have infrastructure as code for the service, and we can put it next to the service code in the repository, like in a separate folder. We can put it in one monolithic repository with like where infrastructure of all services is lying. And then we have the last option where you have like a repository per team, and there are only services or infrastructure of services of this particular team. All right, let's start with the option number one. Service code is in a repository, and you have your infrastructure code for the service defined in the same repository. You can see on the figure on the right side, it's an imaginary repository of an invoicing service with some service stuff. Hello, how are you? Great, thank you for coming. And then eventually you just, it's pretty simple, right? So developers are just like, okay, we have infrastructure for the service, we just put it in the same repository. We'll just call it like infra or .tf or .cfn or something, like a folder for infrastructure, so we have everything clean and tidy and everything. So it's a good solution, right? Just why not? And then you have like a pipeline in your whatever Terraform cloud or whatnot, and it is pointing to this repository and saying Terraform plan or what is AWS CloudFormation CLI something to deploy. Or you could actually even put it in the main pipeline of building your service code. So you're doing like a build, test, deploy infrastructure, deploy service. Why not? Just like you could do that as well. And there are pros and cons. Let's first concentrate on the advantages. So it's very easy to use. You don't need to look elsewhere for infrastructure changes. And for example, when something goes wrong, when you have your house is burning, the service is down, and you don't know what's happening. Something has changed, and just going to one repository, and you see there infrastructure changes and there are changes in the service code. For example, there was a developer that has changed database configuration, and at the same time that some other developer has changed the way the service is parsing the database password from your secret storage or something like this. So there are like two causes of the downtime that happened somehow at the same time, and you actually see both issues and you can fix both of them. You don't need to jump to another repository to like verify if something is wrong or if everything is okay on the other side. It's pretty handy. So like for if you have an on-call team or something, it's really good. So having one or common commit history is really good. Then you also have this really nice thing called Cloud Development Kit. It's not really new. It's been there for a couple of years already, but it's not really widespread, unfortunately. But basically, if you don't know, you can basically use your classical programming languages to define your infrastructure, and then the CDK engine will translate it into your CloudFormation or Terraform templates. So there are like Pulumi, there is a Terraform CDK, there is a AWS CDK for CloudFormation or something like that. So it's pretty cool that when you have your infrastructure in the same repository with service and you're using CDK, simply because you can if you really want to, you can incorporate your infrastructure code into the service code. You can have like classes and functions and that are calling some libraries that are doing like deployment of your virtual machines or whatnot. So you could do that if you really want to. With this solution, that's really that makes it really flexible. And then remember we had like this diagram with services and ownership and stuff like that. So your service is changing ownership from one team to another. What does your team need to do? They're basically just giving the ownership to the other team. They don't need to move, service infrastructure from one repository to another, belonging to some other place. It's just that. It's accomplished. And that also gives developers a freedom how to organize the repository, the code, the infrastructure. They can decide on their own styles. And that's not going to be the case for some of the other solutions I'll present later. And now let's talk about the disadvantages. Of course, all right. No problem. We have some unluck today with the desks. So it is harder to share infrastructure resources between your services. So if you have one service and its infrastructure is defined in this repository, and speaking from perspective of Terraform, it's defined in one state file. You have another service that is also having its own infrastructure with its own state file. And then you need to suddenly, share some of this infrastructure with other service. I'll give you a more concrete example. So we have an invoicing service. It issues an invoice, and it renders it in PDF and uploads it into an S3 bucket. Hello, welcome. It uploads it to the S3 bucket, and then there's this other service. Let's say a CEO signing service that is supposed to pull it from the S3 bucket and sign it with the CEO signature and send it somewhere to, I don't know, customers or whatnot. So basically, what you need to do is that your CEO signing service is supposed to have an IAM permission to this S3 bucket, but first of all, this other service needs to know the S3 bucket name. You could, of course, just hard code it, but it's error prone. We never want to hard code things. We want to do things automatically, and so having different state files makes it really difficult to share these outputs or IDs of resources between different stacks. And for that reason, for example, at Tier, we have built a small solution or a workaround. So we basically are using AWS SSM parameter store to export the outputs of any stack to SSM parameter store, and then use some metadata or some tags, and based on those tags, any other service can pull these outputs and use this data, such as as I said, the S3 bucket name. But again, this is also flawed. You have one AWS account works, but SSM parameters are not shareable between different AWS accounts. Then you have to do more workarounds. You have to have different AWS providers maybe, or switch to Secrets Manager or HashiCorp Vault or Console or something like that. And it's it actually becomes a nightmare sometimes. And remember, one slide ago, I called it easy to use. How is that easy to use? And that's what I want to say. It's a very good solution. It's super, but you probably should think about use cases like that, like when you need to share resources. And if your infrastructure, DevOps, platform, whatever team responsible for all of that is maybe a little bit overloaded or maybe not big enough, then you maybe don't want to go that path, because you won't have enough resources to implement the workarounds that are associated with this solution. Okay. The second option, monolithic repo. What's that? So we have one repository, and it has, oh yeah, it's over there on the figure. You have for example, invoicing service, registration service. Each of them, of those repositories, has only its own service code, no infrastructure code inside. Instead, you have one more repository. You can call it infrastructure, service infrastructure, the infrastructure, whatever. You just put the infrastructure as code of each of those services in there, split it by folder, and that's gonna be it. It basically will all right. Next slide. Yeah, it basically will allow services to share resources between each other because they will all belong to the same Terraform state file. Again, for CloudFormation, it's maybe not really relevant, but like for Terraform stuff, that's what you're going to have. You're going to have one state file, and you're going to have. You don't need to do all those workarounds, and that's pretty good. Unless you have, we have just two services there, right? Two services. You're on Terraform plan, you have like 20 resources or something. What if you have a monolithic repo with 200 resources? Services, sorry, 200 services. A Terraform plan will run for some really long minutes. It's gonna be 5, 10 more minutes. And it's gonna be also pretty dangerous. If your state file corrupts, it becomes a really big issue. Repairing state files is really painful. But that allows you to easily change ownership. Again, if a service goes from one team to another team, they don't need to do anything. They just hand over the service repository, and the infrastructure part stays there. It was in the same repository, it stays in the same repository. And speaking about more disadvantages, your developers will have to decide on the code quality, linting, pull requests. Like, do we want to do a Git flow? No, we want to have a trunk-based development. Blah blah blah. So there will be some aligning between teams, and the more teams you have, the more alignment it will require, and it also will make the repository a bit more difficult to navigate when you again have hundreds of services. And it's going to be also more error prone when you have 35, 45, 55 teams with 3, 5, 10 people each that will collaborate on the same repository. Somebody pushes something into a wrong folder or makes a change to a service that is not meant to be changed or something like that, and then you have a downtime or something like that, or the repository is broken. Oh, who repairs the repository? Oh, what something happened to the pipeline? Shared responsibility. Oh, how does it work? No, not really. It doesn't work. So this solution, it doesn't really scale, at least not at the scale. Like if you have 10 services, 2-3 teams. If you have 20 services, it works kind of. If you expect that your infrastructure will grow, the amount of services will grow 2-fold, 3-fold in the next couple of years, I would say maybe that's not the best approach for you. Oh yeah, I forgot to discuss the CI/CD perspective, because if you change infrastructure only of one service, you ideally want to only deploy one service or redeploy this one service. But as I said, if you have one state file, it will run everything together. And this is it's a waste of time and resources. And there's an option number 3, which is having a repository per team or department or office location, something that makes sense for you and your company. That is something that correlates with the definition of Conway's law. Who was here yesterday on the Pavel's talk? Yeah, one person, 2, 3, 4. Yeah, you remember that he also actually explained the Conway's law. I'll give a brief definition. So any organization that designs a system will produce a design whose structure is a copy of the organization communication structure. So if that's how your organization works, that your teams are kind of by themselves, and or if you have like offices talking to each other, and inside of Office, every developer is like one part of everything, then that's how you could define your infrastructure as code as well. So if you have like this figure on the right side, we have this invoicing service, and we have this team A that owns the invoicing service, registration service, something else, and we basically have this repository per team which holds the infrastructure of services that belong to this team, which is pretty good for developers. Again, the team has its own freedom of choice on how to organize the repository, how to do code quality, linting, whatnot. And it will also reduce the chances that some other team will mess around with your service by mistake. The same issue that we had with monolithic repos. That also allows actually to share resources again with Terraform, because you'll have one state file for this team repository. But the same reason will also start being a disadvantage for it, because if your team owns more than 5-10 services, your stacks will start becoming slower. Deploying only certain changes will become harder. And yeah, the biggest disadvantage is that when the service ownership changes, you have to actually move the infrastructure code out of your team's repository and put it to the other team's repository. And speaking from Terraform perspective, the state file has to be manipulated. You have to run Terraform move and move the resources from one state file to another, and risk corrupting both state files and having some unforgettable nights. So I would say this is a good approach when you know that the teams or offices, whatever you decide, are going to own the services for a longer period of time. I would say at least a year, 2, 3. You would then not have an issue of, for example, if your teams are changing or reshaping every 3 months. Imagine you as they will ask you as a DevOps engineers like, hey, could you please move my state file from this thing to this thing? That will start like dragging down your team. So I would avoid that path if you have more like dynamically changing organizational structure. And speaking of platform infrastructure, again, I'm not gonna discuss what is it, why do we need it, how to do that. But basically, what we just want to know is that there is an infrastructure that is shared between all between all services in your organization or maybe in department, and that could be like VPCs, EKS clusters, artifactories, any sort of stuff that is shared between everyone. So if you decided for one of those three options, you also have to put your platform infrastructure somewhere. So if you have decided for the monorepo approach, then it's going to be pretty easy. You just create one more kind of a service inside of your monolithic repo, and you put your platform infrastructure there as yet another directory. If you went to the service-centric approach, the option number 1, then you can just create a new repository, call it platform infra service, for example, put the infrastructure code there, and you will not have anything else inside. So there will be only infrastructure code, and you can kind of treat it as a service. And if you went with the third approach, the kind of a Conway's law, then you as a, core infrastructure platform team or DevOps team, you probably already have some other infrastructure resources that you own, and you probably will have your own repository for your team as well. So just put platform-related infrastructure in there as well. So that's what I would suggest. And what happened at Tier is why I'm talking about that today, I guess, is that we have learned it in a kind of a maybe a bit painful way, because when the company has started, there was an idea that, or there was a vision that the services are kind of mutable, they come and go, but the teams, they will stay there for a very long time. We believe that they are immutable, they will be there for, as I said, for a long time. And over time, we are proving wrong. Sometimes a team was split into two, services started moving between the teams, departments started being reshaping. As I said, the company is like 4 years old, so there's like a lot of movement. It's really dynamic stuff. And at that point, we have decided that we as a core infrastructure team are a bottleneck, because when a service changes an owner, we had to move state files and manipulate everything, and it was really painful for us. It takes time. So we have decided to shift into the service-centric approach, the option number 1, where we say, all right, the teams might come and go. The teams might move around the services ownership. The product manager decide, okay, well, you take this one, I take that one, maybe it will change, or I'll do you a favor, whatnot. And so we have moved to this approach where a service has its own infrastructure and it really doesn't care who owns it. And we also had, unfortunately, to go away from our CI/CD provider, because that the way it was working, that we had a YAML file that was defining the pipelines, and I was defining the pipelines, and every time when a new team was created, we had to create a new pipeline for its team repository. But teams weren't created that often, or were not supposed to be created that often. But when we switched to a service-centric approach, we realized the services might come and go every 2-3 weeks. We cannot just go and modify that stuff manually. We need some solution that will work automatically. So we have moved from this CI/CD provider to Spacelift, which has a Terraform provider by itself. So we have started to create a pipeline per service every time a new service is created. And how do we know a new service is created is that when a team of developers is creating a service, they have to generate a small YAML file with metadata about the service and put it into something we call a service registry. I've been talking about service registry online for about a year, so I will not really concentrate on that. Just what you need to know, that service registry is just a repository in our GitHub organization that has a bunch of YAML files, where each YAML file is defining metadata for each service we have. And we have a bunch of Terraform resources that are gluing everything, and, for example, create this Spacelift pipelines or stacks per YAML manifest in this repository. And then when you hand over responsibility for a service to the team itself, and you say, well, here's like your infrastructure, and the problem is that developers kind of have their own thing. They have their own deadlines, they have their own goals and responsibilities, and mainly those responsibilities, they are related to the service itself, to the code. They don't really want to know much about infrastructure itself, and especially about infrastructure security, about who can access their database from inside of organization. I'm not talking from like external threats, but some other developer messing around with your databases isn't also, sometimes that's not what they are thinking about. And we also cannot guarantee that every developer is qualified enough to define IAM permissions or policies in the best way possible. Because as I said, they don't have time to do this fine-grained permissions. They have their own job. So what we did is that we have extended our service registry and added there more YAML files for teams, and where each team definition has a metadata on which services do they own. And basically, based on this information, service registry creates more Terraform resources, for example, for Kubernetes, for AWS, IAM roles, and stuff like that, to only allow developers from this team, defined in Okta, to get access to the databases of this service. That's what we have done. And as I said, we have done that in a separate repository, regardless of the way we have chosen of placing the infrastructure code. And again, as I said, developers don't really want to go deep dive into the infrastructure, so you probably want to supply them with ready-to-use solutions, Terraform module, something, so that they can just copy-paste, run, that's it. They have a database. They don't want to know, like, oh, security group, yeah, okay, IAM roles and all that stuff. It takes a lot of time. You just want to make their life easier. So you gotta have as I said, like a registry of your modules that they can just pull online and start using in a matter of minutes. And your modules are obviously also infrastructure as code. So where do you place them? What we do is that we have, again, one more repository. It's separate from anything, but I guess you could think about putting that into your maybe platform infrastructure or something like that. But the biggest threat there is that you have like 35 modules for databases, for, I don't know, S3 buckets, for something, and you have to have them versions independently from each other, which is what do you have in GitHub? Tags? How do you do tags per folder? It starts to be kind of like, and speaking from Terraform perspective, you like semantic versioning also doesn't work when you're using like Git cloning and stuff like that. You probably want to have like your own registry for that. Like from Terraform perspective, again, we're using something we have developed in-house and called boring registry, because boring is just because it just pulls your modules from the S3 and answers HTTP request of Terraform to give it the module. That's how boring it is. But it works. And that's what you should think about when you have your infrastructure as code, not only for the services, but for everything that is around the services. All right. And I have a quiz for you. So having reusable modules means you need to A, store them in a separate repository in the user registry, B, put them in a Dropbox, and C, publish them in a Kafka topic. What's that? Okay. B, you say? All right. It's just a little bit of joking. Of course, it was A, I already talked about. You should have a separate repository for your modules. You don't want to have local modules spread in every repository of your service, because you want to make everyone's life easier and not just the life of a certain team managing a service. So let's wrap up. We're actually pretty good, right? So there is no one-size-fits-all solution. As you saw, there are like options for teams that are big enough to manage a workarounds for the first option, having service-centric approach. There are options that are not really suitable for too big teams or organizations, like the option number 2. There are options that are, or there's an option that is not really suitable for organizations that are too dynamic, like the third option. And what I hope you will leave this room with is, except a little bit of a good mood, is that you will have a kind of maybe a little bit of a cookbook when next time you'll have this dilemma on which way to go, then you might have a look or remember. Did somebody write a note? Anybody? Okay, 1, 2, 3 people. Okay, there are 3 people, so you can ask them maybe. What was this talk about today, if you will forget about it in like 5 minutes or something. So, and now let's have some time for Q&A. Oh, by the way, we have a blog, so I'm actually writing there sometimes. So if you want to know about the workarounds we are building, the service registry or something like that, but you cannot click it. But you just Timur.engineering, you will know that. So questions.